Hello. My name is Mingming Jiang. Today I'll talk about my project. So the name of my project is Zooming and Shrinking Images by using bilinear interpolation. This is the outline of my project. First, I'll talk about the targets, then the motivation, and the background, simulations, result evaluation, and the conclusion. This is the target. First, I'll study the bilinear interpolation, nearest neighbor interpolation, and bicubic interpolation. These three are all basic algorithms of image scaling. I'll write MATLAB code to simulate these three algorithms. First is the nearest neighbor interpolation algorithm, then is the bilinear interpolation algorithm, the last is the bicubic interpolation algorithm. I will also do the optimization of bilinear interpolation. At last, I'll evaluate the results and get the conclusions. Then I'll talk about motivation. Nowadays, image processing is more and more important in our normal lives. People have many requirements about images, such as high quality and large size. Therefore, methods of processing images are very necessary to be raised, such as nearest neighbor interpolation, bilinear interpolation, and bicubic interpolation. These three algorithms will be simulated in this project. Then I'll talk about the background. Bilinear interpolation technology is one of the basic resampling techniques in image processing. It is the extension of linear interpolation. The key idea of bilinear interpolation algorithm is to perform linear interpolation in two directions separately. Similar to the bilinear interpolation algorithm, bicubic interpolation algorithm is the extension of cubic interpolation. The key idea of this algorithm is to perform the cubic interpolation in two directions at a different time. Nearest neighbor interpolation is a simple algorithm. It selects the nearest integer pixels to replace the original pixels when images are zoomed up. Then I'll talk about the simulations. This is the most important part of my project. A scene image is chosen and imported to the MATLAB models of these three methods. The scale factor is 8 to allow the results more readable and easy to analyze. The processing time will be calculated in this project. Optimization of bilinear interpolation methods will be simulated. Next is the result evaluation. First, I'll evaluate the results of bilinear interpolation method. This is the original image, and this is a magnified image by using bilinear interpolation methods. Compare these two images. The magnified one is blurred, especially at the edges of the flower's petals. However, we can still recognize the details in this image. Next, I'll evaluate the results of nearest neighbor interpolation method. This is the original image, and this is the magnified image by using nearest neighbor interpolation methods. We can find that after zooming by using nearest neighbor interpolation algorithm, the image becomes very blurred. There are a lot of big sour teeth at the edge of the flower. We can hardly recognize the details. This means when the image is scaled up, it loses a lot of pixels. Next is the bicubic interpolation method. Still the original image and magnified image. Compare these two images. Except the little blurred in the magnified one. The other part of these two images are almost the same. The edges of the flower are smooth. The details such as the texture of table is easy to be recognized. Then I compare these three methods. Figure 1 is the original image. Figure 2 is the image by using nearest neighbor interpolation methods, and Figure 3 is the magnified image by using bilinear interpolation method. Figure 4 is the bicubic interpolation method. I compare the three magnified images. We can find that the performance of figure 2 is the worst, and the performance of figure 4 is the best. And the performance of the figure 3 is in the middle. The numbers in the parentheses is the processing time of these three methods. Nearest interpolation method costs the least time. It is only 0.73 seconds. The processing time of bicubic is very long. It's about 80 times larger than that of nearest interpolation methods. The processing time of bilinear interpolation method is close to processing time of nearest neighbor interpolation method. It's only about 1.11 seconds. Now I'll talk about optimization. In this optimization, I mainly focus on optimize the edge of the flowers. Compare figure 2 and figure 3. In figure 2, the edges of the flowers has a lot of small salties, and in figure 3 it fixes problems. The edge of flower is very smooth, and the details of figure 3 is much much clearer than details in figure 2. Then I'll talk about the conclusions. According to the results of the evaluation above, several conclusions can be obtained. Nearest neighbor interpolation algorithm costs the least time but has the worst performance. Bicubic interpolation algorithm has the best performance but costs the most time. The performance of bilinear interpolation algorithm is much better than that of the nearest neighbor interpolation, and the processing time still keep low. Therefore, based on the three conclusions, the bilinear is the most useful one in our normal lives. Then, the optimization overcomes the shortcomings of bilinear interpolation methods. It eliminates the saltiness of the edges of the flower. However, the processing time of this optimization increased greatly, so it still needed to optimized. This is all I want to talk about. Thank you. Then I'll run the MATLAB code. I already run the optimized one since it cost a lot of time. This is the figure 2 is images by using bilinear interpolation algorithm, and this is optimized one. We can find that So this one is much more clear. I'll close it. I'll talk about the code. In this program, I first in this program I first processes the bilinear algorithm and then do the post processing. The goal of this program is to eliminate the salties at the edge of the objects in the image. Then I'll run the nearest neighbor algorithm, interpolation algorithm. To magnify the color image, this program divided the image into 3 channels. This is RGB. This is RGB. And these three channels. These 2 channels will processing the nearest neighbor interpolation separately. I'll run it. The image is come out. There is figure 1. This is the original image, and this is a magnified image. It's very blurred. Then I'll run the bilinear one. This is a program of bilinear interpolation. The same as the nearest neighbor interpolation. The image is divided into 3 channels, and then do the bilinear interpolation algorithm. I'll run this. The result is come out. This is the original one. This is the magnified one. Then I'll run the bicubic. This cost a little time. It's about 1 minute. In this program, I also divided the image into 3 channels. Here, he started the bicubic interpolation algorithm. This part is the most important part of this program. Okay, the result is come out. This is image, magnified image. So this is all I want to talk about. Thank you.